Thank you so much, everyone, for joining. As always, this is the Graph Builders Office Hours. My name is Kevin Jones. I'm a developer relations engineer at Edge and Node working on the Graph protocol. I'm also excited today to also have Limone on from Urbe.eth, which is a community in Rome. I would call Limone a serial hacker. He's at all the hackathons, and he's also the winner of one of the recent hackathons that we did for Farcaster. So today we're actually going to have Limone show off his Farcaster Frames project and the integration with the graph. And yeah, without further ado, Limone, take it away.
Yeah, for sure. Thanks for the invitation and thanks for the bounty prize again. Just a little intro about myself. Like Kevin already said that I'm from Rome, from this community, Urbe.eth, with which we run educational activities, research, and we also go to hackathons and sometimes win hackathons together. And that's why, like, I also define myself a serial hacker at this point. I think I've been in like 8-10 hackathons and it's going pretty well. I'm also really a lot into Farcaster, so as soon as Frames came out, I got full deep down the rabbit hole with Frames and built, I don't know, I lost the count actually, probably like 20 of them, both for personal and side projects just for learning, and then like even projects started like reaching out to build some stuff. Primo, yes. And yeah, like we with a friend from Urbe, Frank, we wanted to experiment with frames and on-chain proposals. And yeah, maybe it's time to share my screen. I don't know. Let me see. Okay, so that I can show you what we built. So we were always like looking to find like new innovative use cases for frames, and that's why we built the first frame that was integrated with an on-chain proposal in a Gnosis Safe account. So we made an integration that was kind of like now that frames are accepting transactions finally. When we were building this, we wasn't able to send transactions through a frame. I'm assuming everyone here is familiar with frames, and if I need to like dig down a little bit on how they work, you tell me, Kevin.
Yeah, if you want to just kind of maybe explain at high level, that might be useful because maybe some people here don't know frames. This is the first thing we've talked about frames on office hours. So,
okay, so like frames are an extension of the Open Graph standard that was introduced by the Farcaster team probably 1 month ago at this point. The Open Graph standard is the one that allows application to show website previews in a static way, so both including an image and title, description of the page. And with the frame Open Graph extension, we are now finally able to have some dynamic metadata happening because we can add buttons inside a website preview, as well as dynamic images. This because we can program like this metadata in these frames in a way that whenever you click a button, and you can add up to 4 buttons to a frame, a new action is triggered and sent to the server. Let's see if here that's I don't remember if that's the graph here, but yeah, like basically like you have let's say that this is the first preview. You click get started. The client contacts the server, and the server gets back a new frame with an updated image and new buttons to click. So you can basically create some simple like mini apps inside the Farcaster feed. So going for here on WordCast, there's a feed dedicated to frames, and you can see all the mini apps that people built. Some people built some shops, so frames that you can use to buy cookies, or frames that you can use to mint an NFT, frames that you can use to go through some slides or like whatever. And me and this friend and Frank, we decided to experiment with on-chain safe proposal. So we think that frames are groundbreaking like change for the UX in crypto and Web3 in general. And we thought that they could also help a lot DAOs or whatever, like parties, getting more votes on their proposal, because right now I feel like DAOs are like they don't see much activity happening, not many people vote, both for like gas reason, but also because they don't track this kind of stuff. And maybe with frames, there's a chance to allow more people, or at least like remind more people voting, because they can simply be scrolling within their Farcaster feed and click an approve or a reject button. So very simple interaction, but to get this done, we had to make some workaround because transactions were not out yet again. So what we built basically is Next.js app where we are hosting the frame, and you can see it here, for example. So if I go here, let's hope that this works because it was like 6 weeks ago. It's simple web page. You don't see anything, but the cool thing is happening on the metadata side. So let me see if I can show you what's happening on the debugger here. So this is the frame, and as you can see, I typed in my URL, proposal 6, which is the same one from here. It's just this one is hosted on Vercel. I can actually do the same. All right, and some metadata is being returned. As I told you, there's an image, the supports URL that I'm calling whenever I'm clicking a button, and the button details and whatever. And whenever I click approve or reject, I'm contacting the server, and the server is sending a transaction on chain through a wallet that we instantiated behind the scene. And this wallet is so calling one of our smart contracts, passing by the frame message, because whenever I click a frame button, I'm sending a message to the server, a signed message with my Farcaster keys, and that message can be verified on chain. So there's one guy that created a repository implementing some Solidity functions in a way that you can verify a frame action body message on chain. So what we're doing basically is whenever somebody clicks, and I'm doing it now, it is actually should say that I've already voted. Yeah. And I can also check like the results. But whenever somebody clicks, they are sending a message to our server. We are propagating that message to an on-chain transaction, and on-chain we are verifying that that message is a valid one, and we can also get the user address from the message. And in this way, we can also enforce some on-chain verification. For example, in the case of this frame, getting back to the home, as you can see, we wanted to have a special requirement to vote. So we wanted that only users with an FID, so a Farcaster ID lower than 20,000, was able to send the transaction. And thanks like to this library here, we were able to verify that and propagate the vote only in certain cases. So only if the voter was actually an FID less than 20,000. And about the integration with the graph, was actually a very simple one, but useful because frames have one simple constraint that is about the time limit that action should take. So, for example, on Warpcast, if a frame takes more than 5 seconds to receive back an answer from the server, just like, when I click approve, I have like a max of 5 seconds to update the client. If the client waits more than 5 seconds, they consider the frame broken or something went wrong. So in the beginning, we were trying to read some data directly from the smart contracts, but it was taking like longer than expected, and this was preventing us in making some checks. So for example, whenever I click approve, we're also checking if you already voted a proposal, and we were initially doing it through smart contracts, so like eating up an RPC and fetching the data, and that wasn't working like very well. And the same goes for the proposal status, so like fetching the status, how many people voted, how many people rejected the proposal, and whatever. And at that point, like we felt it was like really straightforward to have a subgraph tracking all these on-chain events, so all these votes happening on chain, And instead of reading directly from the contract, we could read directly from the subgraph that we have here indeed. So we have like two simple objects. One is votes, where we are tracking the votes for each FID, as well as the counter. And then we also have the proposals that are live. So for example, here there's proposal ID 0, ID 1, with all the votes counter, as you can see. Let's get this one, probably has more votes for 6. Let's see. Oh yeah, one more, I guess. I just want to get the last one. Oh yeah, this is definitely like the last one with all the votes that happened on chain. And getting back like the votes object here, we can also check how we are tracking and all these events of people that are accepting the proposal or not with the correspondent FID. Everything that I explained here is open source. So we have this organization called Builders Garden, where we have a lot of open source repositories, both on frames and other stuff. And this application is made of like three repositories. One is the Next.js one that you can check out here. Maybe I can also paste the links later, and everything is well described. So let me see. Can I share the link, Kev? Yes.
Simone's on it for you.
Okay.
Yeah,
amazing.
Perfect. Thank you.
So in this repo, which is the main one, you have all the other links to the subgraph, to the smart contracts, to the addresses where we deployed the safe. So we also did a great work on actually with safe, because it's not only a bounty win for the graph, but we also won a bounty from safe for this project, because we developed a module that you can check. This one that I was showing you is a module for your Gnosis safe. So you can install this module on whatever safe you want, and being able to accept votes on a proposal directly from a frame. So this is something that you should also check in. Very cool, and made by Frank. Was not here with us today. But yeah, I think that's pretty much it. I don't know if I went too fast, but happy to answer any question. And you can also interact with the actual frame just looking in my feed. So I'm Limone.eth. You can go. It's 29 days ago, so you should scroll a little bit, and you can try it out directly from Farcaster. Thank you.
Great, it's awesome. Does anyone have any questions for Limone about this implementation, or any questions about Farcaster frames?
I can also show some code in the meantime. So let me see.
Yeah, actually, if no one has questions, I think, the more you kind of dive into the code is good as well. So it's up to you.
I have a question, but you can wait after the code show.
Okay. So one thing, this project was implemented when Frames.js was at this version, and now they are 0.7.1. So a lot has changed, but it's still working. What I mean is that this is still working, but it's not really up to date, because they implemented a lot more, functionalities, utilities. So maybe some of the stuff that I did in this repository can be done much easily now, thanks to the Frames.js expansions. But I also have other repositories with Frames.js more updated, so you can check them out. But yeah, so I guess I can show you maybe where we used how we use the graph. So let me check. So as you've seen, each frame is coming from whenever I'm hitting this endpoint. This is an actual Next.js page, but it could actually be just a simple HTML return code with this metadata. And with frames.js, you can easily like specify this metadata thanks to their type safety and some utility functions that they introduced. So going back to the code, proposals ID, as you can imagine, is the page that I was showing you. So like proposal 6 was matching with this route, and this is actually the API, so my fault. This is the page. So in this page here, I'm generating the metadata, fetching the proposal from the graph, I believe. Yes. Okay. So this is where it's happening. So I'm getting the proposal through Apollo client, running a GraphQL query, fetching the data, and returning the actual proposal. And this just to set up the proper metadata, and then specifying everything related to the frame Open Graph specification. So specifying the buttons, specifying the image that has to show, as well as specifying the post URL that we are calling whenever we are hitting one of the buttons of our frame. So as you can see here, there are like two URLs. One is the proposal image URL, and another one is the just the proposal API. So going into the API, under proposal ID, I have an image. And again, here I'm fetching the proposal from the graph, from our subgraph actually, and generating an image SVG from an HTML code. This is thanks to Satori. So this is what it's able to render our, let's see, yes. So if I go, for example, on HTTPS, let me copy this URL. If I go here, image, this is not working. Okay, I don't know why, because here it's also showing. Oh yeah, I missed the API. API. Yeah, this is returning our image in a special like format, like it's like 1.91 to 1 ratio, with everything related to the proposal details. So the threshold, the FID requirement, and this stuff. I think it's just hard-coded. Yeah, as you can see, I'm inserting like the threshold dynamically here, as well as the minimum feed requirement that we are fetching from the graph. Because as you can see here in the proposal, we are saving the number of votes that were accepting the proposal, number of votes rejecting it, minimum feed, and also the threshold for the proposal. And this is how we are generating the image. Then if we go on the actual post URL, so this is the API call that we are hitting whenever somebody is clicking approve or reject on our frame. And of course, we want to validate the frame message. We want, again, to get the proposal details, understanding. So if the threshold was already reached, if the FID was like filling up the requirement, and then checking also if the user already voted. So in my case, for example, there's another function that we implemented where you can pass an FID and a proposal ID, and you can check if that specific FID already voted. In this way, if the user already voted, I'm returning this image, already voted image, the one that you can see whenever I click. While if you try that frames, in assuming that you didn't voted, you should see like a successful message. Oh shoot, I lost the As you can see, like if I did not vote, this is also providing a transaction, so sending a vote transaction on chain, passing the message bytes, and the proposal ID. In this way, we're able to like propagate the votes on chain and perform all the required checks there. And this is for like the frame side of things. On the smart contract side of things, I did not work on it honestly, but I show you something. So let me see. Yeah, no, I don't think we have anything here. message verifier. Yeah, these are all like the interfaces like to verify messages, and I can show you like some events that we have, like proposal created event, proposal executed, and we should also have some stuff related to new votes. Yeah, like emit message frame action body verified, and everything is going to our subgraph. Actually, the subgraph is not under the Builder's Garden. Yeah, it's under another one. Oops, no, it's not this one. I need to. I think I send it to. Okay, this one. If you want to check the subgraph, and here we were tracking again like two simple events. One it's about the vote event, and one it's about, yeah, as you can see, message frame action body verified is the event that we've been seeing here. This one, and then we're also tracking the proposal created event, so that on our subgraph we both have all the proposal and all the votes needed to check everything in a much faster way in our frame. That's it, I guess.
Very cool. There was a question here in chat. I know someone had a question as well, but do you think this might be something interesting to see for DAOs to implement voting on Farcaster? Have you thought of anyone doing that or seen anyone doing that? That was from Mike.
Yeah. So not sure like this actual implementation makes like sense for DAOs, but it's for sure like an idea that it's definitely will be useful to DAOs. So being able to vote from a Farcaster frame directly from the feed, I think that will increase a lot the vote percentage. And there are like other projects already working on it. For example, that's Voctoni, I believe that they implemented some frames to allow on-chain polls. And I'm also expecting actually maybe, I don't know, like Prophouse or like these platforms where community are running on-chain proposals and all this stuff to sooner or later like integrate their frames so that their communities can actually vote directly from their Farcaster client that they prefer. So if not this one, because it's a bit clunky, I'd say, I'm sure that among the transaction use cases that we will see on frames, we will have voting proposals on DAOs. That for sure.
Very cool. Simone, I believe you had a question.
Yes. Well, what was the question? What is the latest in terms of tooling? Can you show a little bit more maybe about this frames.js? So this one is just this port 3010 is just frames.js CLI or something?
Yeah. This is so behind the scenes I'm running this process here. It's the frames.js starter. So not only they have a library that you can use to build frames, but they also implemented a debugger for frames so that you can easily test your frames locally, both like inserting a remote URL, but also inserting as I showed you in the beginning, you can also check localhost 3002. Was this one the port? Yes. And this is actually one of their latest releases. I believe they implemented this new debugger 2 days ago, and it's very useful. A lot of like utilities that you can use to move around different steps of your frames. You can check the data that you're sending to the server. You can check the metadata that is being returned. you can log in with your Farcaster user, but you can also mock or impersonate another user. So it's really useful for testing purposes. Here, for example, you have also the HTML tags that they are actually embedding. And another cool thing is one about the mockup. So a lot of frames out there, they are requesting users to following their account or recasting the frame, liking the frame cast, and with this mockup you can also mock the state. And then you also have a lot of resources here. So the best one for sure, like these awesome frames, again, it's full of libraries, that example frames that are also, simple lemon frame, I guess, is mine. And other stuff that I built as well here. So it's my go-to SDK for sure, or library or toolkit to build frames.
Yeah, I added you to these awesome frames, like all the windows of the hackathon. So you said like that they also launched the feature of sending transactions directly out of Farcaster. How does that work?
Yeah. So it's kind of new, so I still need to dig more into it. But this is the first frame. This is the first frame implementing a transaction, and they simply like use this frame to gift somebody a storage for their Farcaster activity. So a very simple use case. There's already a specification that has been running around for a week. I believe we can find it here. Farcaster frame. So it's something that they share with the community exactly 1 week ago. Getting some feedback first. Let's see if it's maybe it's for maybe I have it in my this one, frame transaction public draft. So basically there are a lot of like security concerns. So that's the first disclaimer that I wanted to say, because it's still risky to run transactions through a frame, because you need to trust whoever built that frame. So they are trying to put in place some reputation mechanism that fits well in the Farcaster ecosystem, because you have an open social graph that you can use to check if you trust somebody or not. But still they are putting some sort of like allow listing or whitelisting to allow people sharing their frames, at least on WordCast, and allow with transactions. The main changes with respect to the current state of frames that I showed you is that to execute a transaction through a frame, you need to return back this kind of data from the server. So you need an API endpoint that is able to compute the data for the user that is interacting for the frame. So let's say that I want to transfer some USDC to Kevin. I'm sending a call to I'm hitting the button on the frame, and the frame should answer the client with the transaction encoded JSON. So that encoded JSON from the client can go to the wallet connect kit or whatever you have instantiated in your browser. So first thing to mention is that you're not using your custody Farcaster address behind the scenes, but I think that you will be required to sign a transaction through your MetaMask, let's say. And then the other thing is that they are still allow listing domains, especially like on WordCast. So on WordCast, if you want to create a frame and post a frame that allows users to execute a transaction, they need to allow list you. Otherwise, they are here you can check the security checks. Otherwise, they are saying to the user, some suspicious requests or do not proceed. All this stuff that we already seen with the redirects. I didn't mention it. I didn't mention redirect action because in my frame they weren't. But basically, like before transaction, there were like two actions possible. The first one was the post action, calling an API and returning the new frame image and buttons. The second one is the redirect, and whenever you want to redirect somebody to your website, they are already showing the user an alert saying that it might be a risky and non-trusted domain. With transaction, of course, like this stuff becomes even more dangerous because you are asking people to execute a transaction coming from an untrusted domain, maybe. And so if you're not allow listed, they show this red alert instead of the yellow one. You see, like connecting wallets.
Yeah, it's cool. I mean, it's pretty cool, no? Like to do more on-chain stuff. For sure, like everybody has already signed some stuff with its wallet that we shouldn't have, no?
Yeah, no, indeed, I'm not scared actually. So some people are very scared. I'm honestly like excited and I want to play around with it. I did not test this one already, but I want to test it and then maybe build something for sure. And I think it opens a lot of possibility. Of course, like we need all to be cautious and find ways to make this work. But I think it will be another like game-changing things for the frames ecosystem, which is not only Farcaster related, because you can implement frames in, for example, they are working on frames with XMTP right now. I'm not sure if you've seen frames into the Converse app, but it's possible to have like frames wherever you have behind the scenes an ED 25519, I guess, the one that it's also using for Farcaster. So it's not properly an Ethereum address, so an Ethereum pair of key, but it's still something that you can use to sign these kind of actions.
Very cool. Any questions for Limone? So what's next, Limone? What's the next Farcaster project you're going to build?
So for sure, I want to build a frame, a frame integrated with transactions. Not sure yet what, because I've been busy in Denver, so I wasn't able to focus that much on this specification and even like coming up with ideas. But for sure, I want to build something with it. And then I'm also planning to see, like with Frank and Paolo from Builders Garden, we're also planning to build a new mobile client for Farcaster, actually.
Very, very cool. Great. Any more questions at all about Farcaster frames or what Limone showed off? Awesome. Well, this is a really, really great session. Thank you so much, Limone. I really appreciate you coming on. Thank you so much. And look forward to seeing you next week in London. And sure. Any other questions from anyone else, just feel free to drop them in chats. We'll kind of hang out here just a little bit longer for the office hours. So if you guys have any questions, let us know. But Limone, again, thank you again for coming. And thank you. Very nice.
Yes, thank you again. Thank you again for the invitation. And if you want to reach out, like I'm on Farcaster, Telegram, Twitter, wherever. It's always Limone.eth. So my DMs are open.
Great. Thank you.
Looking forward to meet in London again.
Sounds good. Thank you, Limone.
Bye-bye.